Good day, Sir PJ and our fellow classmate. For today's video, we're gonna show you how to solve a rational equation and a rational inequality. Have fun learning!
Hi everyone, Rachel and Natural here, and for today's video objectives, we should be first, able to define a rational equation, second, as well as rational inequalities, third, solve the rational equation, and fourth, solve as well the rational inequalities. Let us first define the rational equation and rational inequalities. Rational equation. A rational equation is an equation containing at least one fraction whose numerator and denominator are polynomials. Rational inequality. A rational inequality is an inequality that contains a rational expression where a rational expression is a ratio of two polynomials. Now that we know the meaning of rational equation and inequalities, my friend Ariel Sanggalang will show you how to solve the rational equation.
Hi everyone, I'm Ariel. I'm going to show how to solve rational equation. To solve rational equation, the first step would be A. Eliminate the denominator by multiplying each term of the equation by the least common denominator or LCD. B. The second step. Note that eliminating denominators may introduce extraneous solution. Check the solution of the transform equation with the original equation. Now that we know the steps, let us try to solve this equation. 1 over y equals 6 over 5y plus 1. First, let us equate this equation to 1. 1 over y minus 6 over 5y equals 1. Next, we need to find the LCD. In this solution, the LCD is 5y. Then, we will multiply the LCD to the equation. 5y times 1 over y minus 5y times 6 over 5y equals 1 times 5y. Cancel the like terms, then the answer will be 5 minus 6 equals 5y. Upon multiplying it to the LCD, we get the 5 minus 6 equals 5y. Next is we will combine like terms. 5 minus 6 equals 5y. Negative 1 equals 5y. We will divide both sides by 5 to get the answer of y. Negative 1 divided by 5 equals 5y divided by 5. Cancel the like terms. Then, the answer is negative 1 over 5 equals y. The answer to this equation is y equals negative 1 over 5.
Now, we're going to solve a rational inequalities. We pick the 3 over x minus 3 is less than or equal to 2 over x plus 2. The answer of its critical points are x is equal to negative 12, x is equal to 3, and x is equal to negative 2. My friend Marisol Saldivar will show you the solution in solving this inequality.
Good day, sir, and my fellow classmate. I will show you the step-by-step of how to solve this rational inequality. For the first step, rewrite the inequality as a single fraction on one side of the inequality symbol and 0 on the other side. As much as possible, make the numerator and denominator in factor form. So how are we going to do that? So first, we're gonna transpose it. After that, we're gonna have to do cross multiplication and copy the denominator, and then factor it. After that, combine similar terms, hence the answer is x plus 12 over x minus 3 times x plus 2 is less than or equal to 0. Then get the critical point. So, it will be x plus 2 is equal to 0, then transpose it. So, the answer would be negative 2. Then do it to the other. My friend Irish here will show you the sign table.
Hello everyone. Now that MC finished explaining the steps in solving the rational inequality, I will now show you guys how to solve the rational inequality in the steps 2 to 4. Step 2. Plot the critical numbers on a number line. The zeros of the denominator will not be included in the solution or not shaded. The zeros of the numerator will not be included or not shaded in the solution if there is no equal sign below the inequality symbol. Otherwise, the zeros of the numerator will be included in the solution. To know if the critical numbers is part of the solution is by substituting the critical numbers to the original inequality. In step 1, we identify that the critical numbers are x is equal to -12, -2, and +3. Now we're going to substitute these critical numbers to the original inequality. We will substitute -12 to the original inequality. So 3 over -12 minus 3 is less than or equal to 2 over -12 plus 2. Next is 3 over -15 is less than or equal to 2 over -10. And the answer is -1/5 is less than or equal to -1/5. The answer is equal and it's true, making the -12 part or included in the solution. Next, we're going to substitute -2 to the original equation. So 3 over -2 minus 3 is less than or equal to 2 over -2 plus 2. Next, 3 over -5 is less than or equal to 2 over 0. The answer would be undefined, making the -2 not included in the solution. Next, we're going to substitute the 3 to the original inequality. So 3 over 3 minus 3 is less than or equal to 2 over 3 plus 2. Next is 3 over 0 is less than or equal to 2 over 5th. The answer would be undefined, and making this number 3 not included in the solution. Now that we know if the critical numbers are part of the solution or not, we're now going to step 3. Step 3. Identify the intervals made by plotting the critical numbers. Choose a test value in each interval and construct a table. The sign of the rational expression at this point is also the sign of the rational expression at the interior point in the aforementioned interval. In our number line, we can say that we're going to have 4 intervals. The intervals are open to -infinity and close to -12. Next is close to -12 and open to -2. Next, open to -2 and open to 3. Next is open to +3 and open to +infinity. Now that we know the intervals, we're going to choose test points or test value. In our first interval, we choose -13, next -3, +2, and +4. Next, what we're going to do is we're going to substitute -13 to the given. So, -13 plus 12 is equals to -1. So, we're going to put negative sign. -13 minus 3, that is equal to -16. So, we're going to put negative sign. -13 plus 2 is equals to -11. So, we're going to put negative sign. Now, we're going to substitute -3 to the given. So, -3 plus 12 is equal to 9. So, it's positive. And -3 minus 3 is equals to -6. So, the sign is negative. And negative 3 plus 2, the answer is negative 1. So it's negative. Next, we're going to substitute the test point positive 2. So 2 plus 12 is equals to 14. So it's positive. And 2 minus 3 is equals to negative 1. So the sign is negative. 2 plus 2 is equals to 4. So the sign is positive. The next test point we're going to substitute is 4. So 4 plus 12 is equals to 16. So it's positive. 4 minus 3 is equals to 1. So it's positive. And 4 plus 2 is equals to 6. It's positive as well. Now, to know the sign of the f of x in the lower part of the table, we're going to multiply the signs. So, in the first intervals, we're going to multiply negative times negative is equals to positive, and positive times negative is equals to negative. Next, we're just gonna repeat the process. So positive times negative is equals to negative, and negative times negative is equals to positive. The third interval is positive times negative is equals to negative, and negative times positive is negative. Next, the last interval. So, positive times positive is positive, and positive times positive is positive. After getting all the signs for f of x, let us now proceed to step 4. Step 4. Use the table to determine which interval satisfied inequality. If the inequality is of the form f of x less than 0 or f of x less than or equal to 0, then all intervals with a negative sign are solutions. If the inequality is of the form of f of x is greater than 0 or f of x is greater than or equal 0, then all intervals with the positive signs are solution. According to the rule, since f of x is less than or equal to 0 is our inequality, all our intervals with the negative sign will be the solution. Hence, the solution is open to negative infinity, close to negative 12, is union to open negative 2, and open 3. Now, let us look at our number line. We can see that the negative 12 is shaded, and negative 2 and positive 3 are hollow, because negative 12 is the only critical number that is part of the solution.
Now that we have shown you how to solve a rational equation and a rational inequality, I hope that you have learned something from it. See you next time. Bye!